Because of its multifunction design, the Mura IPX was built to handle a wide variety of colors and display scenarios. In this video, we'll review principles of image display, color mixing, color spaces, and chroma subsampling. Each display on the market, whether a TV, a monitor for a PC, a laptop computer, or a device with an integrated screen, such as a tablet or a phone, all display images starting at the same level, the pixel. A pixel is a tiny, illuminable square capable of displaying any one color at a time. Like a tile in a mosaic, pixels are a single sample of a larger image. When the pixels are aligned properly and presented as a whole, a complex image is perceived by the viewer. While we perceive each pixel as just one color, pixels are actually made up of 3 subpixels, colored red, green, and blue. By combining varying values of the subpixels, it is possible to produce numerous different colors at the pixel level. Because displays are by default black, the simplest way to display an image is with brightness only, also more commonly known as a monochromatic image. Each pixel in a monochromatic image is simply displaying a different percentage of brightness. As seen before, by mixing red, green, and blue, it is possible to display a whole spectrum of colors. This is referred to as RGB additive mixing. This possible spectrum is referred to as the gamut of RGB color. If red, green, and blue are mapped mathematically on 3 axes, like a computer would, this creates a cube of all possible RGB color. When a computer displays color, memory is required to compute the information. By uniting neighboring increments of each color, computing power can be saved. RGB 888 allows for 256 increments of each of red, green, and blue, for a total of about 16 million color combinations. More recently, stronger computing power has allowed RGB 101010 to become useful in applications and available for wider use. 101010 is a much more precise color, allowing for 1024 increments of each color with over 1 billion possible color combinations. Able to handle both RGB 888 and RGB 101010, the IPX allows color to be as well defined as the user may need. Another way of looking at color is to divide it into 1 brightness channel and 2 chroma or color channels. One technology that employs this method is YUV color. Since early broadcasts transmitted only monochrome signals, this ingenious system allowed for the incorporation of color. By combining the luma and 2 chroma channels, it allows for full color definition and image quality on the receiving end of the transmission. Mura IPX can provide YUV color at 8 and 10 bits per component, offering high detail in the YUV color space as well. Matrox Mura IPX 4K capture and IP encode-decode boards have been built to provide enhanced capabilities for video walls, multi-viewers, and personal video walls. Mura IPX records and streams high-quality H.264 encoded video to any device with H.264 decoding capabilities over IP at low bit rates. The single PCI Express board allows for simple, low-cost installation while delivering advanced capabilities to your network-based video wall controller, all managed with either the Mura Control for Windows or Mura Control for iPad software. To learn more about Mura IPX's other features, visit matrox.com/graphics/Mura IPX.